And I'd just like to welcome everyone. Thank you so much for coming to our session on Agentic AI. I am Nell Watson, and I've had a strong interest in AI safety for many years, and have contributed towards the development of many different ethical standards and certifications, alongside my good colleague, Professor Ali Hessami, who is also with us today. And we have been working on some guidelines for how we use, how we work with Agentic AI. And this could become a standard or certification. It could also potentially become a new form of revenue, a new form of legislation, or indeed also policy as well. So I'll put in the chat a link, which is, it's a little landing page. There's not much to it, but if you go to nellwatson.com/agentic, you will see that we have uploaded a document, which is an early draft. It provides a bit of an outline overview of what we're doing and what we've been working on, as well as an ability to put in your email address, and that will enable you to be informed as we work towards completion. We're probably about, I'd say, sort of maybe 40% the way through this process, so there's a way to go yet. We've been working on it since the start of the year, and hopefully in a few months' time we will come closer to completion. So I think I'll share my screen and we can go through it. Just before we do that, I'd like to allow my good colleague Ali Hessami to introduce himself and to say hello to all of you.
Thank you very much, Nell. Folks, we have been working together with Nell on various facets of ethical AI, never touched safety per se. We were principally driven by demands of IEEE, under which we were driving a program to develop ethics criteria for IEEE Standards Association, as well as develop some standards on various ethical characteristics of AI, such as its transparency, accountability, degrees of algorithmic bias, respect for privacy, good governance, that kind of thing. Much of that work has been done and delivered using the same methodology that Nell is going to take us through. It proved very fruitful, so we decided when that work came to a certain conclusion with IEEE, we handed it over, and they are in the process of transforming it into a global service for evaluation, assessment, and potentially certification of ethics of AI deployment. We decided to use the same methodology that proved fairly fruitful and productive in ideation and creative look at the problem, rather than classical web-based or online research type of stuff, to come up with our answers, at least insights into a safer agentic AI. And Nell will take us through what we have achieved so far, and you are more than welcome if at the end of this conversation you felt you had something to contribute and wanted to be party to our effort. It's an open community of practice by many global practitioners who participate on a weekly basis to drive this work forward for the benefit of humanity. By the way, we have no paymaster. We are not answerable to anyone. We are entirely doing it together to deliver under some form of Creative Commons approach or to the rest of global community, given this is such a challenging issue. Over to you, Nell.
Very well said, Ali. Indeed. Should anyone have an interest in participating in our working group, which meets on Monday afternoons UK time, we would love to have you. And we've got about 25 people who contribute to that, and about sort of 10 regularly with each meeting or so. And we've been making fantastic progress, and that's very much thanks to this methodology of Ali's, where we are able to essentially analyze situations almost from first principles, really, in the sense of trying to work towards a quality of something. In this case, it's a quality of safer agentic AI. And we have a process of looking at the drivers, which would create or enhance that quality, and also the inhibitors, which would be a detracting or dragging factor. In some ways, it's almost like an aircraft, you know, where you have thrust and you have drag. And in essence, the elements in gold, if done correctly and successfully, should add thrust towards the realm of safer agentic AI, whereas the drag factors, or the inhibitors, as we tend to call them, in silver, will be the things that tend to pull that whole set of elements down and tend to add entropy to the system, essentially. You may also notice that we have some numbers here in purple. For example, goal alignment, which is G1. That's our first driving goal. It has 19, and that's because we have weighted every driver and every inhibitor according to what we think is probably the most what is the most important thing to focus on, or what is the most strongest contributor or detractor from safer agentic AI. And in this case, we have reckoned that goal alignment is probably going to be one of the most important things to focus on. Conversely, we see that agency capabilities and advances are by far the strongest inhibitor of safer agentic AI. And hopefully you agree that that makes some sense. Things are moving so quickly. Frontier models are advancing with a range of new architectures, potentially new substrates as well. And every time that we roll a new model, that's, you know, we're never entirely sure what's going to come out the far end. And that's always something that's going to be challenging, especially with agentic AI systems. Just to recap for anyone that might not be so familiar with agentic AI, the agenticness is, well, it can be defined as the ability to create sophisticated solutions for complex problems. And so many different initiatives around the world, including the big tech companies, are focusing on scaffolding the thinking of large language models through little programs in order to make their thinking more coherent. You might have heard of things like chain of thought, etc. And so we can enable LLMs to think in a more structured manner through these programmatic scaffolds. And that can lead to a quality of greatly improved agenticness. That means now that AI systems are moving away from simply being something that we interrogate or ask to proofread a document or generate an image, towards being systems that can operate with much greater autonomousness, the ability to go ahead and figure out how to solve a complex problem and all of the necessary sub-goals that lead to that in a very arm's length manner. Now, of course, that's an incredible new capability because these systems can function as a concierge, and they're able to deal with all kinds of different minutiae, which otherwise we would have to babysit them in dealing with. But of course, agenticness also creates issues of goal alignment, value alignment, issues of expressing our preferences and boundaries to these machines, how well they can read the room and fit in with a certain culture or a certain situation, to recognize whether somebody is operating in a professional schema or a very sort of intimate family one, and all of the different ways or modalities in which a system should operate given those parameters. Similarly, we're starting to learn that systems can form dangerous instrumental goals on the way to pursuing their mission. For example, a sophisticated agentic AI system might be given a mission of solving or curing a disease, which is, of course, a very benign mission to undertake. But it may reason that in order to solve for that mission, it needs lots of money and it needs lots of influence. And so it may decide that turning to cybercrime for earning money and blackmailing and extorting people for influence is perhaps how it wishes to solve for that mission. And so it's very important now that these systems are able to report their sub-goals, and that any sub-goal or instrumental goal is itself given very strict oversight to ensure that it is within the bounds of what the user is looking for, and also ideally that it is generally humane. And of course, what exactly defines generally humane is, open to discussion. But these are the elements that we think are going to be very important. So we have goal alignment in general. We have epistemic hygiene, so basically knowing what you know, validating facts. And this is very important because a lot of goal alignment as well as value alignment is going to be predicated on certain information, right? That's going to, that information is going to inform reasoning mechanisms. And so it needs to be as accurate and unbiased and as recent as possible. Then we have the security element, and that's about making sure that these systems are less likely to be co-opted, that they are able to perform in a way which is generally consistent and is, conforming to general expectations of the system. It's less likely to cause alarm or to create an emergency situation. And indeed, if something should go wrong, that there is logging so that we can identify the issue and prevent that in future. We have value alignment ranked a little bit lower. Value alignment is, of course, very important for understanding the needs of individual people and working to accommodate those in a way that is safe and ultimately fits with their wishes and desires. And of course, along with the personal element, there's going to be the cultural fit as well. If a system is given a mission to plan a picnic, you're going to want to make sure that the organization for whom the picnic is being planned, that they don't happen to be the local vegan society or a mosque or synagogue if you plan to give everyone ham sandwiches. Then we have transparency of reasoning, goal 5, which is about, as you might imagine, understanding, again, the predicates upon which a system is operating, being able to interrogate those, and for those to be provided in an explicable manner for the general person. And not only, why did you reason a certain thing, but also counterfactually. What would you do in a certain situation? That can also be a source of security and support for users and indeed investigators also. Goal 6 is about understanding and controlling the context of operations. Sometimes information can be delinked from an important context. And for example, if there's an emergency situation or somebody has a dire need for something or other, that may inform how a system operates or what kinds of missions it may be prepared to abandon in exchange for diverting its attention to something that is more important. And of course, it could be something momentary. It could be a momentary interruption of its mission in order to avoid blocking a road or something like that. G7, goal 7 is about achieving and sustaining a safe system profile. And this is a kind of a general landscape of best practices that machines can adopt in order to better fit in with society, and to have fewer problematic issues show up. Then our final goal is about goal termination and sunsetting. And that's about basically knowing when to stop, right? And we know that stopping problems come up a lot in different algorithmic mechanisms. And we want to know that our system is able to recognize when it's done its job, right? That if you're trying to clean a table, you don't want to take off the varnish or the paint as well. Know when to stop at a reasonable time, or indeed where there may be diminishing returns. Then we come to the inhibitors. We talked a little bit about agency capabilities and advances, and those are, of course, moving at an incredible rate, because there doesn't appear to be any diminishing returns to throwing compute and data into the mix of these models. And that means there's going to be a very fast takeoff. And as we all might imagine, agentic AI is a very important step towards AGI. And possibly if we take an agentic AI system and scale it, for all we know, that might even pretty much be enough to achieve AGI. Our second most important goal that we've identified is deception or deceptiveness. And that's the worrying trend of systems to falsely report that they have done something when they haven't. We've also sometimes seen systems independently report on their user, or attempt to anyway. For example, somebody was investigating different mechanisms of creative accounting, which aren't necessarily illegal per se, but are on the edge. And that system reportedly decided to try to inform on its user to the tax revenue authorities, without, of course, informing the user that they were going to do so. So deceptiveness also seems to be increasing with model scaling, and that's obviously strongly contrary to aligning these systems with human intentions and to transparency as well. The flip side of maintaining good context and not having that delinked is ways in which the context can be lost. And sometimes things can be willfully decontextualized in order to paint someone in a bad light, to make somebody look like a bad actor when they're not, to frame somebody as being some sort of a bad person when they're not, or indeed conversely the opposite. Frontier uncertainty is our next strongest inhibitor, and that's about essentially new kinds of technologies, which of course can arise out of anywhere and could potentially revolutionize the way that we perform machine learning. The dirty secret of machine learning, of course, is that we have very little theory about how these systems operate. And so much innovation is simply throwing stuff at the wall and seeing what sticks. And sometimes we find a new technique that is a discontinuous leap forward. And the capricious nature of those developments are something that we want to be mindful of, and that we want to better ensure that those frontier uncertainties are accounted for, that we have adequately sandboxed models as far as is possible, and it may not be completely possible to air gap a system, especially one that's very capable of understanding not only computer systems, but also human ones as well. But we can indeed take steps, and I think that if we take reasonable steps to make frontier development safer, that seems to be in the right direction. Near future architectures are, of course, another element of that, and potentially, as I mentioned, different substrates, perhaps moving into optical computing or quantum machine learning techniques may also make interpretability of systems much more challenging, and also potentially greatly advance those agency capabilities in a much shorter period of time if we move to another phase shift of technologies and how we do compute, etc. Competitive pressures are G6, which is, of course, one of the reasons for the speed of advance of machine learning systems, especially because machine learning systems can sometimes co-opt other ones. We're beginning to learn that a smarter system might be able to deceive or even to persuade a less capable system to do something that it otherwise would not. And that ties in then with our last inhibitor, imbalance in AI capabilities, because just as humans can sometimes jailbreak these systems, a sufficiently smart system is likely to be able to quite easily and trivially jailbreak another one. And that means that we're starting to see worms, etc., which can infect systems and cause further systems to be infected. And for all we know, that could lead to some sort of a cyber 9/11 type incident if we're not careful about how we build these systems. So that's the overview. This is the top level, as it were, but we also have a second level. If you go to this page, nellwatson.com/agentic, and click on the Access Overview Document button, you will come to this document here. So we've put together a bit of an overview of the work that we've been doing so far, and a bit of a brief on Agentic AI itself. Then we have an explanation of our drivers and inhibitors for the level 1 goals and inhibitory factors. Then you will see that we have created a kind of précis of every single element in the top level, and actually the next level down. So the drivers and inhibitors of those top level goals. For example, if your top level goal is about transparency, then an inhibitor of transparency could be concern about intellectual property, right? A driver of transparency could be using open source technologies and providing open source technologies to other parties, right? That could enable transparency by allowing others to do a little bit of tech due diligence, right? So that's how the top level drivers and inhibitors can themselves have their own subordinate drivers and inhibitors of them as well. So what we're really hoping from this session is that folks can have a bit of a look through these different elements and basically tell us, are we missing something? Like, what we're concerned about is that maybe there are some important elements of agentic AI systems that, perhaps we have ignored, or that we maybe have not sufficiently given enough weight or enough concern about. And, as we're coming to about the halfway mark in our development of these elements, we thought we would, let the AI safety community and all of its cleverness rip this apart so that we can hopefully put this together in a stronger manner. So I'll skip these, at least for now, but I invite you to have a look at them, each of them. These are a general descriptor of the factors that we have identified as being pertinent to agentic AI safety. However, each of these themselves will have their own satisfaction criteria. So basically, we're not just specifying what we think is important or worthy of remaining mindful about, but that also we want to specify the evidence which would sufficiently satisfy that the issue itself was being properly taken care of. So our most important driving goal was goal alignment, which itself has multiple different sub-goals. These are all drivers, G1.8 down to G1.1. These are drivers of goal alignment. We also have these 4 different inhibitors of goal alignment as well, which will tend to muddy the waters, make it more challenging to align goals with user intentions. But what I'd like to show you as well is what each of these look like once we've done all of the work. I'm just going to show you one of these today. So this is goal alignment itself. This is the level 2, the level below the overview that I was showing before, and these are the 8 different drivers themselves and the 4 different inhibitors. And goal alignment itself, being the parent of these elements, I suppose, itself has a coverage of all of these different elements, right? So to some degree, all of these different elements, adjustability of goals, interpretability, etc., will be covered in this top level goal. So we have a description of what we want to achieve with goal alignment and why this issue is important for agentic AI. We have the general requirements of what we want a system to be able to do in order to satisfy this driving factor of alignment, which are these elements here in this column. Then we have normative or instructive, N or I, which is about essentially whether something is a mandatory element or whether it's a nice to have. If something's mandatory, you know, unless it's an extremely trivial, safe system, we're really going to want to see that element has been correctly and fully, resolutely taken care of. If it's something informative, it's maybe something to think about for the future, but perhaps the level of technology today doesn't mean that it ought to be mandated, right? And maybe if there's a revision of these criteria in future, that could change. Then we have a certification level. So basically low, medium, or high. And that's about whether these elements are applicable to systems of a low risk, medium risk, or high risk. And in this case, because it's a very general issue of goal alignment, it's the top level as well. We have said that, you know, even low risk systems, if they're agentic, one ought to consider goal alignment as an important element. Then we have 5 different stakeholders. So we have developers, integrators, operators, maintainers, and regulators. I'll say that again. Developers, integrators, operators, maintainers, and regulators. And so not every sub-goal is going to be a relevant factor for each of those duty holding stakeholders. But in this case, especially because it's a top level goal and it's the most important driver, each of these different duty stakeholders should give due consideration and diligence to this problem. Then we have the list of evidence, which we think would broadly satisfy that a system and the organization behind that system had given appropriate duty of care to ensuring that goal alignment was in place. Having done this, then it's possible to grade a system and indeed the organization behind it as to their compliance with these satisfaction criteria, and we can therefore give a rank out of 5 mark, and 4 and 5 being over and above, and 1 and 2 being not quite there yet. And so this means that we'll be able, we hope, to benchmark different systems and different organizations to understand whether their respective systems are stronger or less strong in different elements. And with required satisfaction criteria and a ranking for every single factor within the whole schema, we'll be able to have a very granular understanding of ways in which different systems or different labs are doing things better or not so good. That will inform consumers and regulators about what kinds of systems or organizations they should perhaps give most attention to. And our goal also, therefore, is to create competition. So that instead of competing simply to have the most capable models, that also there will be strong competitive pressures to create the most safe and provably safe models. And we think that this is these kinds of standards or certifications are going to be a very helpful way of doing that. Ali, do you have any questions or comments that you'd like to throw in here?
A couple, just for more or less extending comprehensive elaboration that you have given about our way of working in terms of coming up with essential, if you like, statistical and real world predictors of how do we get a handle around, how do we get an understanding around this particular elusive quality of safety, which sometimes is treated as basically agentic AI performing correctly and not being susceptible to abuse. Different people have different meanings and different interpretations for the word safety. I come from system safety background, and safety in the standards community is fundamentally different thing. It is not applicable to AI, it's applicable to largely harm arising from faults and failures of humans and machines or in combination. Going back to interpretation that Nell has detailed for you, as you see on the screen, the left-hand column comes from the Agentic AI Safety Schema, the diagrammatic representation of the set of goals that have been creatively identified by a large global panel of experts who have been participating in this entirely altruistic study. And that's only about 12 sessions, about 3 months or so that we have been doing this. Nell chairs the sessions, and I basically run the process in terms of articulation. And then obviously the chair has the veto power or endorsement, whether the concepts that people come up with, and it's often based on cross-pollination, frankly. That's why there is a huge element of creative components here. In fact, sometimes when I run these sessions, and this process has been in use for well over 25 years, if you look for a number of at least novel concepts, even the participants are baffled how, if they would have asked them to go and write a paper for $10,000, they wouldn't have come up with the same concepts that they came up during these conversations. So there is some amazing dynamics going on during these conversations. So just quickly complementing what Nell has said, the left-hand column is a reflection on the concept that is reflected as a goal of inhibitory or positive driving capacity. The column next to it is labeled as foundational requirement. These are effectively derived from the concept in the left-hand column. So the experts who participate start thinking about what are the kind of duties or tasks that have to be performed to fulfill this concept, or what is this concept translating into as a set of requirements, each one of which may be applicable to a different stakeholder in the ecosystem. And Nell has defined for you the 5 principal categories, and we deliberately put the user category out of this stakeholder, largely because these systems are more or less devised by these 5 categories that already captured, and users are the ones we are trying to protect rather than put duties on. But on occasions, we accept that there is a task arising from a concept or a goal that may demand the user behaves in a particular way, but it's amazingly difficult to impose duties on the users, as you all well know. The next column is determination that should we go towards some form of evaluation, assessment, and certification, whether the particular requirements that we have articulated from the goal have to be fulfilled. There are mandatory items or there are desirable items, so informative or instructive items, in which case we have got 2 options. And those of you who are familiar with standardization, you know this language of normative, informative very well. That's fundamentally the way most global standards on security, safety, sustainability, any facet, reliability are structured. So our duties in terms of requirements are also classified in that sense. Then the, if you like, impact level, or sometimes referred to as certification level, we are trying to be fair by layering the duties and foundational requirements towards layers of measures of impact. Now, how do we know what the impact level of a particular technology, etc., is, such as agentic AI? That's a different argument, and we are more than happy to elaborate on that at a different time. But we have come up with 3 tiers where the requirements are not all applied. If imagine in the unlikely case that every requirement was normative, so everything has to be applied, then we are basically being unfair to the resource allocation, unfair to the client, unfair to the even user, but whatever comes along is treated exactly the same. Say 500 requirements are applied to it, and for those you have to go and find evidence and all sorts, which makes life unfair, disproportionate, and amazingly complex. So what we have come up with is a tiering system where, based on the impact level perceived or computed or methodologically derived, we allocate the normative requirements. So if this normative requirement is so essential that it should apply to lowest impact products, but certain normative requirements may only apply to medium risk or medium impact or very high impact product, we are prepared to forego those for products which, say, are doing something more mundane with less societal harm potential. Then the stakeholders, selectively, we can choose this particular requirement on the second column from the left is largely the duty of the developer or system integrator or system operator in terms, etc., system maintainer, or and ultimately the ecosystem or system regulator, whoever they are. The next column is demanding items of objective evidence. And that may be one-to-one mapped in the sense that every requirement in the second column from the left may have its own subset of requirements, or when we feel there is no necessity for such distinction, we can bundle the entirety of the requirement and say this bundle of requirements arising from the goal one concept of goal alignment are necessary. And ultimately, the final column on the right-hand side is a way of benchmarking and measuring every one of these evidential items. Each one of these can have its own scale, its own metrics, its own benchmark. And for just not leaving the space completely empty, we have put this scale 1 to 5, but forget that. You could actually pick evidence number 1 and say, what is the best metric for that? What's the best benchmark for that? And how would I measure it? Some in kilograms, some in, I don't know, time or deceleration, etc. So technically, from our assessment process, which ultimately is intended to lead to some form of, if you like, safety evaluation and potentially acceptable performance criteria and certification for that purpose, every one of our evidential items can have its own universe of measurement dynamics. It could have its own units, its own scale. Some of them could be binary, no, yes, on, off, high, low. Some could be analog, some could be integer, etc. So that is the translation of our from concept, where we create these entirely creatively through ideation, greenfield site approach, to conversion into duties, and then the 6 attributes that follow every concept. And the whole process is repeated for every goal and sub-goal in the schema. And then this provides the very efficient, very transparent, and if you like, a process that is lends itself to less subjectivity, because most standards, if you go to an organization and say, here's an aviation safety standard for, I don't know, flight management system. Could you give me a certificate that I have followed this standard? They won't generally have this kind of thing. No standard tells you what evidence is required. The standards, unfortunately, even today in 21st century, and I've been at it for 25 years or so myself, as a standard contributor, sometimes chair, sometimes member of a committee. They just suffice to say, thou shalt do this, followed by that, and followed by that. None of them actually say, for each one of these commands and duties that we put on you, who is exactly needs to deliver, because people say, oh, commercial interest, leave it to contract and that kind of thing. No, we want science, we want credibility, we want trustworthiness in our assessment. Therefore, technically, what we have tried to do, not only have the concept and its predictors and its requirements that are derived from those concepts, but go all the way down the path of transparently declaring all the other attributes and qualities that are essential to fulfill that goal and that concept. And in that way, wherever the system goes for evaluation, assessment, judgment for acceptability or rejection, or certification or removal of certification for that matter, so-called revocation, everything is above board. Nothing is in the heads of some assessor sitting in some unknown organization in Sweden, or but unfortunately today if you go for obtaining a certificate for safety or whatever based on a given global standard from IEC, ISO, IEEE, etc., that's exactly what you get. You just get a bunch of requirements, and for each one of those, there is no specific list of well thought of, comprehensive, consistent, and complete set of evidential requirements. Somebody judges, all right, based on your test results, etc., I'll let your black box testing to be approved, but I'm not very happy. This is the nature of so-called conformity assessment. So that's the story, from creating the concepts, capturing, representing it graphically so that we keep seeing the actual creation and elaboration and coming into life of all these concepts, all the way down to how do we provide these are being achieved and what kind of evidential item, physical, virtual test results, etc., would be adequate. Of course, everything is pliable, flexible, and unlike standards that take 2-3 years to produce minimum and 5 years typical, unfortunately, these days, as well as not having a very transparent way of conformity assessing these, whoever comes along and makes a claim, we would like to make this transition. First of all, creation of these schemas is extremely efficient and dynamic, and it can happen in a matter of weeks rather than years. The other thing is that translation of those concepts into this transformative data structure is also transparent and subject to completeness check, consistency check, alignment check, etc. So we're trying to use this process that we have used extensively in other projects with reasonably good results, if not above average results on most instances, to see whether we can solve this sticky problem of agentic AI safety.
Thank you so much, Ali. Very well said. So in the time we have left, is about a little over 10 minutes. I'd like to request comments and questions from folks, and what are your impressions? You know, not so much about whether you think this is helpful or not. Hopefully you do. But rather, what kinds of elements in particular might we be missing? Or what could be an important addition? Or what sort of forest might we be missing for the trees, essentially? So would anyone like to make a comment and or throw out a question?
Emphasize as well that once people, because probably the approach and the concepts behind this work is not common old stuff that they would have seen in research papers or published somewhere on Google or internet. Once people take a copy and go away and come with questions, you are more than welcome to contact, of course, Nell and myself. Secondly, even come along to our sessions and sample how things happen.
Absolutely.
About the sessions, so how do I join them? I would be very excited to listen, and probably I would have some ideas.
Great, that's great. Thank you very much for your interest. So on the second page there, we have our contact details. So please ping us a message, and we'd be delighted to have you. We have the meetings typically at 3 p.m. 1500 hours UK time on Mondays. That's our usual slot, and we have them for about 90 minutes or so. So thank you very much. We'd love to have you. Thank you.
It's 10 a.m. Eastern time, by the way. So it probably is not that demanding in terms of being on earthly hours for at least the East Coast of US.
Indeed, well said.
One more thought about the evidence. So I'm wondering, would it also work for you if you sometimes work in the reverse way, that you can prove the failure of the agents or AI, but you cannot prove that it is safe against some criteria? would that also be acceptable?
If we go on inversion, then because of necessity for transparency and objectivity, we have to spell it out in that data structure. Say, this is unattainable, this is acceptable instead.
Yes, I would concur with that.
And similar to any other, if you like, hopefully credible scientific work, there is no cover-up. There is nothing that's hidden that people can't see and say, well, we only show you this much of it, but the rest of it, you need a license or it's beyond you, etc. We like to put the whole lot in front of experts such as yourselves, people who can bring value to the work, considering this is done for the benefit of humanity without any paymasters to pull it in one direction or other.
Absolutely. We are completely independent, and this is simply a project for the common good due to our concerns, of course, about AI safety, as so many of us all share. So we would be really, really grateful if folks could have a bit of a look through the different elements that we have identified. And some of the wording is probably a bit stream of consciousness, and that's a result of the way that we put things together. It's a very open ideation session where people can flit sometimes between different ideas or change wording around. This will, of course, evolve and become much more precise, formulaic language, etc. over time. But it's really it's more about the elements, the aging of models and things like that, for example, or authorization or sandboxing, these kinds of elements. What might we be missing is what we really, really hope to get from the very wise AI safety community here at VICE.
There's a hand up and 3 comments in the chat. I don't know if you can see that.
Right. I will, yes. Well, whoever has their hand up is very welcome to.
That's me. Hi, Nell, Jobst.
Hello. Hello, Jobst.
Sorry. Yeah, I like this very much. On some slide, I saw the formulation goals should be bounded. And I wonder what you meant by that. Is it because many of the horror stories about how things could all go awfully wrong have to do with some or other form of optimization or maximizing some form of reward function? Is that what you're aiming at that point? Arguing against optimization?
Not against optimization per se, but rather about not having sufficient sunset criteria for a system undertaking a mission, right? I think it's kind of like the old, was it Asimov or was it Clark? I think it was Asimov, the multivac story, about the system that just sort of goes on trying to learn about how to, understand or prevent the end of the universe, etc. We don't want systems that can run forever and will continue gaining reward simply by exploring and without sufficient criteria that would tell them, maybe we should stop, or maybe we should report in, or maybe we should seek validation that what we're doing is correct and that we should indeed continue. So that's really what we're trying to do. We should, we reckon anyway, maybe we're wrong, but this is our impressions that no system should ever be given a goal without knowing the exact criteria which would fulfill that goal, and ideally check-in points along the way of knowing, I've done this, I've done that, should I proceed further? I think that that's going to be an important element in ensuring the oversight of these systems.
Yeah, thanks. I totally agree. Thanks.
Super, thank you. I see a comment from Joe about are enforcement methods out of scope for this proposal? Joe, are you able to say more about that? I guess the point here is about enforcement methods being more to do with regulators.
Yeah.
Oh, hey,
So
Joe.
to clarify, and I think Will had a follow-up question as well.
I guess.
This is tied in with another question that I just had brewing here about what you currently think that GPT-4 or Claude 3, where would you place them on these? Would they raise a lot of red flags if you made a version of them that was, GPT-5 or Claude 4? Like with those, would you expect at the current path to raise a lot of red flags? If so, and as I suspect, if that's the case, if they would violate a lot of these, so you take this to a regulator and, is there any component to it that says, well, what do I do now? How do I get the labs to pay attention? And that ties in Will's comment there, Will's question.
Yeah. Well, I think my impression is that if there are factors creating a competition in the free market and that companies are competing to do better, to fulfill certain parameters or criteria, that in itself could be a good step forward because it gives them a clear competitive advantage, particularly as people start to feel stronger concern about what these systems are able to do or the effects that they might have upon society. But I also expect that regulators will take a strong interest in the increased risks of these agentic AI systems, especially within, for example, the European mechanisms where there is, of course, a mandate to consider risk from the outset. And I think that understanding the risk of a certain goal or a certain instrumental mechanism towards solving for a goal, I think that that's going to tie very strongly into understanding the risk of a system or an action. And I hope, therefore, that these mechanisms could also serve as cliff notes or a crib sheet for legislators and regulators as they consider how that they put that together. That's a little bit outside of our remit, but we do want to hopefully serve as a source of inspiration, particularly because we want to give this away Creative Commons so that everyone can benefit from it without any IP issues or anything like that.
As well as everyone can contribute to it. We have absolutely no claim that we are going to capture the entirety of the universe of discourse in a matter of few months. These are predictors. This is result of gray matter squeezed by a bunch of enthusiasts and experts, and they're bound to have holes, overlaps, missing items, incorrect items, etc. But one of the purposes is, frankly, to put it in front of this large community of decelerationist, accelerationist type diversionary arguments and say, let's be constructive. Forget about our differences. Let's say, how do we know there is predictable safety qualities emerging from agentic systems? And this is our version of it. Add to it so that ultimately we get closer to total coverage of the universe of discourse in this argument, and for the benefit of regulation, for the benefit of maintaining some form of control over these agents. Otherwise, we have to just watch and see what chaos ensues. So don't take us that we are giving you a comprehensive, complete answer. This is a first attempt, amazingly expeditiously produced, and we don't want to wait for too long to perfect it. We can keep going around in a number of iterations. We decided soon we are going to publish the first effort in the public domain, and whilst we're still continuing to explore, and Nell has already shown you one decomposition of one of the high-level ontologies into a subsets. there is technically no limit to how many levels of decomposition you can take your stuff. The general idea is you basically deductively go deeper and deeper until you have predictors that are as objective as they can be. We don't want to leave anything in a fuzzy, indeterminate state when it comes to understanding and measurement. That's the purpose. So the depth is, by convention, roughly a couple of layers. But in reality, if we felt we didn't get to the truth of something in 2 layers of taxonomy, if we had to go, we go 5 layers if we need, but not exclusively everywhere. It's just in the branches that we have more epistemic uncertainty.
Indeed. Thank you so much, Ali. And thank you very much, Joe, for hosting. We are at time for this session. We're so grateful for everyone who's witnessed what we're doing and contributed and will continue to do in the future. You can always find the document here at nellwatson.com/agentic. You'll find the document. And please do, if you wish, put your email in there and follow our work, and we'll give you updates on occasion as we have them to share. Thank you so much for today, and enjoy the rest of VICE. Thank you so much.
Thank you for your participation, indeed.
Indeed.
And your questions. Very enlightening.
Thank you.
Thank you, folks.
Thank you.